Okay, welcome to lesson 15 and 16. The topic of pressure is quite a large one, so I've decided to split this into two videos. So, in the first video, we're going to be looking at the pressure equation, which we did in year 9, and then we're going to be looking at a new equation called the fluid pressure equation. So, we'll go to the first part, pressure. Now, if you remember my lesson, we always started with somebody laid on a bed of nails sandwich, and they're breaking the world record. So it's a load of people, and they have these nails on the bed, and some lunatic lays on them. There's their legs and their feet. And then, in this case, they have another bed of nail sandwich, and someone laid on top, and so on and so forth. And the question is, how do they survive? And eventually, between the group, we come up with the sentence, force is spread out over the area. Now, that sentence within it actually tells us what pressure is. I'm going to go through my highlighter. We'll go through with light blue. Force spread out over an area. Let's go for the operator here. I'll show you what I mean. Over. Now, over, if we write two numbers, A over B, well, what we've done is divide them. So here we've got the symbol for over. And what we end up with is the equation pressure. Pressure equals force divided by area. And we can put that in a triangle if that's our thing. And we end up with path. Pressure is force over area. Path equation. Now, the units for this, twofold. One is you can have newtons over meter squared. So you can write it like that. However, a French scientist and mathematician a long time ago called Pascal, and you may be called that, I think maths call their classes after scientists. So what you may see is it written as PA. So 1 Pascal is equal to 1 Newton per meter squared. And to put that into context, if we were to find out what the atmosphere is of the planet Earth, so the atmosphere of the gas you're breathing, which has a pressure, and we go pressure of atmosphere, we will see it is 101,325 pascals. So let me write that down, 101,325. So 101,325, put a comma there, PA. So what does that mean? It means that there is 101.3 kilopascals. Or, if you wanted to think, if I had a meter squared sheet, how much force, how much pressure is acting on this thing, then there is 101,325 newtons over every meter squared. And if you were to create a box, a meter squared vacuumed box, so a meter on each side, and you took all the air outside, then you would have over 101,000 newtons pushing on every surface into that box, trying to crush it out of existence. To put that into context, 101,000, if you divided that by 10, you're looking at 10,000 kilograms of weight. So if you were thinking about 10,000 kilograms on the floor, that is the amount of pressure that would be pushing in on every surface. So that's the pressure equation. Hopefully you're quite familiar with it. Put it in a box, highlight it so you don't lose it in all your notes, because there's lots of them. I'm going to put it in pink, make it jump out at me. There we go. So that's pressure equation. Hopefully should be ringing a slight bell. People doing the bed of nail sandwich. Right, so now let's apply that to this one. Imagine you're underwater. So as you go underwater, it gets painful. And it gets painful because the pressure starts pushing in, particularly on your ears. Your eardrum is very sensitive to pressure. And so you start getting squeezed by the water from all directions. Ooh la la, ouch. There we go. Now, if you go deeper, that pressure is going to increase upon you. You're getting bigger, but not really, but the pressure's getting bigger. So, what's causing that? Well, one of the reasons is water has a density. And if you remember, we use the symbol rho for the word density. Now, we studied density in paper 1, topic 3. So if you don't remember anything, have a quick look in your revision guide. Go over to paper 1, topic 3, particles. And we talk there all about how Archimedes discovered the density of gold to discover that the king's crown wasn't actually made of gold. And he ran up the street shouting, Eureka, I found it. So that's density. And we write the symbol rho, pronounced like that, rho. Okay, so water has a density. Also, we have height, the column height. So column height. I may have spelt column wrong. Who knows? We have column height. Okay, and the deeper we go, the bigger that height. And finally, pulling all of that down, obviously to the centre of the earth, is gravity. So putting all of this together, we can actually calculate the pressure acting on somebody. We just times everything together. So we take the height in meters. We take the density. So the density of the liquid. Let's get everything moved over here. There we go. The density of the liquid, and that is given in kilograms per meter cubed. Kilograms for every meter cubed of the water times gravity. And gravity will tell you how many newtons for every kilogram you have. Okay. Now, written out, we'll write it out algebraically as I prefer it as rho g h or hg rho. It's up to you. It's all multiplication. Oh, let me get back to my previous lesson. Flashback. Rho gh personally works for me, but it's up to you. Put it in a box. Get the highlighter. Highlight it there. Okay, now let's have a look at it in action. So what if you swam to the bottom of a 3 meter deep pool? So let's give it a go. So, rho of water, let me write rho properly. It's got a tail on it. Rho of water is, density of water is 1,000 kilograms per meter cubed. Gravity is 9.8 kilograms per meter. No, what am I doing? Newtons per. I'm going to sneeze. I do that every time I record myself. I always sneeze. Don't know why. Let's get back to it. Newtons per kilogram. There we go. And the height, the column height, we want to go 3 meters underground. Okay, so pause the video, have a little go, see if you can get the answer. While you're doing that, I'm going to try and work it out myself. Hopefully you've paused it. Really paused it. There we go. Okay, and you've pressed play, and so we times them all together. We end up with an answer of 29,400 newtons per meter squared, or we could say 29.4 kilopascals. About a quarter of atmospheric. Remember, atmospheric was 101. So about a quarter of atmospheric pressure if you swim 3 meters down. And that's why you can feel it in your ears. You know, a third of the pressure acting as it would normally. If you go up high, then if you come out of the water and you leave the fluid that you live in, the atmosphere, then actually it will hurt again, but the other way. Because then the pressure is bigger inside your head than it is outside. And again, your ears will hurt. So I'm going to stop that. I'm going to call that lesson 15. In the old book, it's on page 58. Don't know what the new book is because I haven't got one. But have a little look, cross-reference, make some extra notes, try the questions on the bottom of the book. Take care.